Hello everyone, it's Natalie. In this video, I'm going to use an example to talk about my very simple method to solve general chemistry and general physics questions. I found in tutoring both chemistry and physics, oftentimes the hardest thing that students need to figure out is how to solve the question or what the question is really asking. So once they know the process, they're able to follow the steps. But actually figuring out what the question is asking and how we can get to what it's asking can be burdensome. And so I break it down into three questions. First, ask yourself, what are we looking for in this question? What is our answer going to be? What kind of units will it have? What is the meaning of it? That's the first thing we need to figure out. Second is we need to look at what we know. What are we given? Because we don't really know how we're going to get to where we're going if we haven't looked at what we're given. And then finally, we need to map out how will we get from what we know to what we are looking for. And so I'm going to walk us through this question and go through those three steps. So always start with the end of the question. What mass of sucrose in grams is contained in 3.50 liters of this solution? So what we're looking for here is mass of sucrose. And some things that we know 28% sucrose solution by mass. We know density. So density equals 1.118 grams per milliliter. And we know volume equals 3.50 liters. Now there is a disagreement between units here. Our density unit is in grams per milliliter and our volume is in liters. But something really important to keep in mind is that grams per milliliter is going to be the same as kilograms per liter. So I'm just going to convert right now and now call this 1.118 kilograms per liter. And why that is because kilograms is times 10 to the third and milliliters is times 10 to the negative 3. And so if you move something that was in the denominator that was times 10 to the negative 3 and you make it just liters or the middle unit, something on top then can be times 10 to the third. And so let's look back at the question and see if there's anything else that we need to pull out from here. Now, I don't see anything else, so let's move into our mapping. How will we get from what we know to what we are looking for? So I can see that we have density and we have a volume and we want to get a mass. And so we can make a ratio with the density and known volume to solve for mass. And this calculation is going to give us the overall mass of the solution. So then the next thing that we need to do is multiply the mass of the solution to get the mass of sucrose. And just to get even more specific here, so our first step is we'll use ratio with the density and the known volume to solve for the mass of the solution. And then we will multiply the mass of the solution by the mass percent of sucrose to get the mass of sucrose. And so this is a really simple two-step problem. It's always important in your mapping to see if there's any information that you need to gather from your periodic table or other resources. And here, there's nothing that we need to do. There's no need to convert to moles or anything along those lines. So let's go ahead and get into it. We have 1.118 kilograms per liter is our density. So this is going to equal X kilograms of solution over 3.5 liters. And I always say use your units. Do not ever drop your units because your units are really important in making sure that you're staying on track with your solving. If your units cancel at the end to give you the unit that you want, you know that you followed the right path. If you end up with a funky unit at the end, you know something has gone awry. So as we can do when we have ratios like this, is we can cross multiply. So we multiply 3.5 liters by 1.118 kilograms, and that is going to give us 3.913 kilograms times liters. And this equals X kilogram times 1 liter. So we know that our X, or our mass of the solution, is just going to be 3.913 kilograms. And now all that's left to do is multiply 3.913 kilograms by 0.28, the mass percent of sucrose, to give us 1.09564. But we certainly don't want that many sig figs. How many sig figs do you think will be appropriate to keep? Well, let's look at the question. There are 3 sig figs in the mass percent, 4 sig figs in the density, and 3 sig figs in the volume. And so we will get 3 sig figs at the end. So this will round to 1.10 kilograms is our mass of sucrose in this solution. And now we're done. Thank you so much for watching. I hope you found this video helpful.